A data perimeter in AWS is a set of preventive guardrails that help ensure that only your trusted identities are accessing trusted resources from expected networks. While there are several different ways to implement a data perimeter, your three primary tools are going to be one, using an AWS service control policy to define your outermost perimeter to control the maximum permissions for your principals across all your AWS accounts in your AWS organization. The second is network based, using AWS VPC endpoint policies to control which principals, actions, and resources can be accessed using a VPC endpoint. And the third is a resource based policy that controls access based on the identity and the network from which the principal is making a call. While a resource based perimeter can help prevent unintended data disclosure caused by misconfiguration, the challenge comes with asking, how do we operationalize this at scale? Because today there are over 200 services in AWS, and even if you try to use KMS keys, which integrate with most services, trying to audit each key policy for each resource to verify our data perimeter controls becomes a management nightmare. And if we need to make a global change, updating policies becomes another operational overhead for our security team. At Thales, using our CipherTrust Cloud Key Management solution, you can set a schedule, or you can manually start to discover and get an asset inventory of all your KMS keys that are part of your AWS organization. Once scanning has been completed, you can start to audit and manage your KMS keys across multiple accounts and even between multiple regions, all from a centralized management console. Now, instead of having to audit and manage each KMS resource policy, you now have a central place to create and store your data perimeter policies for all your AWS accounts. As you can see, I have a list of data perimeter policies, one for each one of my AWS accounts. Now, if I look inside the policy for my Thales Crypto Labs accounts, we can see that I have 7 KMS keys assigned to it, and the key policy associated with each key, making it a lot easier to audit and manage our preventive controls. Now I'm going to switch to my second Chrome window, where I'm logged in as root under my Thales Crypto Labs accounts. And under the key management service, if I select custom managed keys, we can see that I have 7 keys total, but because of my data perimeter controls, not even root is able to view and manage my keys from the AWS console. However, there is a key in a disabled state which root seems to still have access to. If I select the key and look at the key policy, I can see that this key is using the default policy. Even though the key is in a disabled state, I still want to make sure that I can minimize the risk of someone unintentionally re-enabling the key or scheduling the key for deletion by reinforcing my data perimeter controls. So now, if I switch back to my CipherTrust Cloud Key Management console, go back to looking at my AWS keys, filter down to my Thales Crypto Labs accounts, here we can see the disabled key. And if I select the key, we can see the same metadata and proper information that root was able to see from the AWS console, which also shows us the default policy assigned to it. To set my data perimeter controls on this key, I'm going to click Select from Policy List, select my policy from the drop-down menu, click Apply, and then click Update. And if I switch back fast enough, we can see that root is now denied access from viewing and managing the key. And here's the key that was disabled just to show how root is no longer authorized to view or manage any of the keys. So far, our data perimeter controls are working as intended, but now let's assume that the security team has received the request to grant the root user audit access only in order to review the data perimeter controls. So now let's switch back to our CipherTrust Cloud Key Management console. And instead of having to update each resource key policy individually, we now have a single policy where I can manually make the necessary changes to meet the needs of my organization. So now if I click Update and then click Apply, we get a notification that my policy change is being updated across all keys that are associated with this policy. And once we receive another notification that the policy has been updated successfully, we can switch back to our AWS console as root, and just like that, root is now able to audit our keys once again. Just to confirm that root is not able to do anything else but to audit the keys, I'm going to reselect the key that was disabled. Now as root, I can see all the property information about the key. Now let me get rid of this error real quick. And under the key rotation, we can see that root is only able to view but not make any changes. And if root tries to schedule the key for deletion, he's going to be denied access. Now those are my key management perimeter controls, But what about the controls for the assets that we care about the most, which is our data? Here, under the S3 service, I have the single Thales CryptoLabs bucket, which if I select it, I can see that I have two objects. If I select the data perimeter objects and try to open it as root, root is denied access because root has not met the conditions defined by our data perimeter controls. However, if I switch over to my third Chrome window where I'm logged in as CryptoAlice under the same Thales CryptoLabs account, under the S3 service, I can see the same bucket that root was able to see, and inside the bucket are my two objects. If I select the data perimeter objects and now try to open it, CryptoAlice is able to access the objects because she has met the conditions defined by our data perimeter controls. But do you know what the best part of using Thales CipherTrust clock key management to establish your data perimeter? With CCKM, you can go beyond using native keys and start to bring your own keys or even hold your own keys, giving you even greater control over your keys and data.